In today's video, we are going to see the fourth lab component of digital design and computer organization. Design a 4-bit full adder and subtractor and simulate the same using basic gates. Here we have 4 full adder circuits, that is F0, F1, F2 and F3. We have the inputs carry in for all the full adders, and A0, B0, A1, B1, A2, B2, A3 and B3 are the inputs, and some we get as S0 here and S2 over here, S1 as here and S2 over here and S3 over here. Here C in, A0 and B0 are put as input. We get C out as an output. This output goes as input for F1, and A1 and B1 are also the input. We get S1 as the sum and we get C out. This C out is again the input for F2. Here A2, B2 are another two inputs, and we get S2 as our sum and C out. This C out is input for F3, and A3, B3 are another two inputs. We get sum as S3 and the C out. We'll now implement this method using Verilog program. Here A, B and carry, sum, borrow and difference we have taken. A from A0 to A3, B from B0 to B3 are our inputs, and the two outputs are carry and borrow. The other two outputs are sum and difference, that is sum S0 to S3 and difference as D0 to D3. We have the other wires which are C1, C2, C3, C4, B1, B2, B3, B4. C1, C2, C3, C4 are for addition, that is for adder, and B1, B2, B3, B4 are for subtractor. Here we input A0, B0 and carry as 0 for F1, and we get the output sum and carry 1. Here we input A1 and B1, C1 as input, and sum 1 and carry 2 are our outputs. In F3 we input A2, B2, C2 as our inputs, and we get sum 2 and carry 3 as our output. And in F4 we input A3 and B3 and C3 as our inputs, and we get sum 3 and carry 4 as our output, and we assign the carry as C4. In the subtractor, similarly as in adder, we input A0, B0 and borrow as 0 as our inputs, and our difference will be difference 0 and borrow 1 will be our output. Similarly, we write for other 3 gates, other 3 subtractors, and we assign borrow as B4. Now we'll declare those by, that is full adder. A, B, C are our inputs, sum and carry are our outputs. Here this is for 1 bit, this will be followed for all other bit, all of them. We assign the sum as A XOR B XOR C, our equation for full adder, and we'll assign carry as A and B, or A and C, or B and C, which is our equation for full adder carry. And the same way we assign for difference and borrow for subtractor. And after, when we run this program, we get the output like this. Thank you. In the next video, we will see the fifth lab component of digital design and computer organization. Thank you.